Good morning, distinguished reviewers, session chairs, and fellow researchers. My name is Imeliana Jopi, and I'm an undergraduate double degree student in Entrepreneurship and Information Systems at Bina Nusantara University, Indonesia. It is my honor to present our research titled Success Factors of IoT-Enabled Digital Tools in Entrepreneurship, a systematic review integrated with Delphi validations at the International Conferences on Digital Technology-Driven Engineering, or ICDTDE 2025. Specifically, in the first international conference on digital tools in constructions for efficiency and sustainability, DIGISUS 2025. This study was conducted together with my co-authors, Hizkya, Raka, Priananda, and Shandy, Aulia, Jaya, under the supervision of Agung Purnomo and Yulia Magdalena. In recent years, the Internet of Things has become a foundational technology for digital transformations. IoT enables entrepreneurs to build automated, data-driven, and interconnected vendor models supported by smart infrastructures. The urgency of studying IoT adoptions continues to grow, especially as global disruption and smart city initiatives highlight IoT's role in enabling business continuity, resilience, and innovation. However, entrepreneurs still face major challenges such as limited infrastructure, readiness, interoperability issues, and fragmented digital ecosystems. These barriers slow down adoptions and prevent vendors from realizing the full potential of IoT-enabled solutions. Therefore, examining how IoT contributes to entrepreneurial success is increasingly necessary. The literature indicates meaningful progress in IoT-related entrepreneurship research, particularly across sectors such as healthcare, industry, digital platforms, and educations. Nevertheless, as the slide highlights, current findings remain fragmented. We lack an integrative understanding of which factors consistently drive IoT-enabled entrepreneurial success. For this reason, our study aims to consolidate existing knowledge through a systematic literature review and then validate this insight through a Delphi study involving domain experts. Our purpose is to identify key success factors that enable effective IoT integration in entrepreneurial context and to formulate future research directions based on these findings. This research employs a full integrated methodological approach designed to produce both conceptual clarity and empirical robustness. We began with a systematic literature review following Prisma Gilden's using Scopus Index Journal publication from 2020 to 2024. This approach ensures transparency and consistency in identifying and screening relevant studies. Next, we apply the Gioia grounded theory method to analyze the selected articles. Through this method, we identify first-order concepts, develop second-order terms, and consolidate them into aggregate dimensions. This structure process allows us to generate a theoretically grounded success factor framework directly from the literature. To strengthen validity, we conduct Delphi validations through expert interviews. This expert review challenged and refined the emerging conceptual model, ensuring that the success factors are not only theoretically sound but also aligned with practical realities in IoT adoptions. Our research is guided by two core questions. First question is, what are the primary success factors that support IoT in entrepreneurship? And the second question is, what are the future research directions for the IoT in entrepreneurship studies? This question frame that analytical process and guide our contribution to the literature and practice. Using the Gioia method, we identify four aggregate dimensions, each consisting of multiple second-order terms and first-order concepts, derived from the 23 review articles. These dimensions represent the foundational pillars that consistently support successful IoT adoption in entrepreneurial contexts. I will explain each dimension in more depth. First, digital entrepreneurial human capital. This first dimension focuses on the knowledge, skills, mindset, and learning behaviors that entrepreneurs must possess to leverage IoT effectively. It highlights the entrepreneurs as the central decision maker whose human capital directly shapes IoT adoption outcomes. The second order terms within the dimension include 1, entrepreneurial learning and capability development. This refers to the continuous learning processes that enable entrepreneurs to develop IoT-related competencies. It includes structured training programs, hands-on experimentation, and exposure to IoT tools, analytics, and prototyping. 2, entrepreneurial mindset and human capital. This then captures the need for cognitive readiness, such as creative thinking, problem-solving ability, comfort with uncertainty, and openness to technological innovations. These traits influence how entrepreneurs evaluate IoT opportunities and design digitally enabled solutions. Together, these dams show that IoT success depends not only on technology itself, but also on the entrepreneur's digital literacy, design thinking capability, absorptive capacity, and commitment to lifelong learning. The second aggregate is digital organizational readiness and culture. The second dimension concerns the international organizational environment, which must support IoT adoptions through strategic alignment, cultural openness, and coordinate operational structures. The main second-order terms are one, organizational culture and change. These them emphasize the importance of culture that embraces experimentation, tolerates risk, and support innovations. IoT adoption often requires organization to rethink existing routines and empower employees to adapt to new systems. 2, organizational integration and data-driven operations. This related to integrating data flows across departments, developing standardized digital processes, and implementing data-driven decision-making routines. Without integrations, IoT data remains underutilized. And 3, digital workforce and organizational learning. This then addresses the need for digital talent, training initiative, and mechanism for organizational learning. Firms must invest in upskilling employees and creating knowledge-sharing environments to fully leverage IoT. Collectively, this dimension reveals that IoT adoption is most successful when supported by strong leadership commitment, cross-functional collaboration, governance mechanism, and a culture of continuous adaptations. The third aggregate is digital technological infrastructure and innovation systems. The third dimension highlights the technological foundation required for entrepreneurs to implement, automate, and scale IoT-driven ventures. Its second order terms includes one, IoT and ICT infrastructure readiness. This involves reliable connectivity, sensor networks, device interoperability, cloud computing, and data storage capabilities. Without basic IC readiness, IoT integration cannot occur. 2, Industry 4.0 infrastructure and smart integration. This DEMS reflects advanced technological components such as automation systems, cyber-cycle integration, robotics, and smart manufacturing processes. These technologies enable IoT to generate operational intelligence and efficiency. 4, 3, innovation and system integrations. This then covers the capability to link IoT system with other technologies such as AI, data analytics, or blockchain. It includes R&D support, prototype facilities, technological experimentation, and innovation partnership. Together, these DEMs suggest that IoT entrepreneurship requires not only the availability of technology, but also the ability to integrate, secure, and scale it within broader innovation systems. And the aggregate 4 is digital value creation ecosystem and societal impact. The fourth dimension shifts the focus toward external value creation and the broader role of IoT in shaping markets, ecosystem, and society. Its second order terms include one, digital opportunity creation and customer value. IoT creates opportunities for personalized service, predictive analytics, automation-based efficiency, and new customer value propositions. 2, business model innovation and service innovation. IoT enables entrepreneurs to design new digital business models such as subscription-based data services, platform-enabled marketplace, remote monitoring, and sensor-driven service delivery. Third, 3 is ecosystems, platforms, and networks. This then emphasizes the importance of collaboration with digital platforms, industry partners, universities, and government institutions. IoT-driven ventures rely heavily on networks for data sharing, interoperability, and innovation scaling. And the last four is smart cities and sustainability and societal impact. This themes captures IoT broader contribution to sustainability, smart city development, environmental monitoring, and social well-being. Entrepreneurs play a role in designing solutions that benefit communities, not only businesses. Overall, this dimension illustrates that IoT success increasingly on the depends on the ability to build ecosystem synergies, innovate new value proposition, and contribute broader digital transformation agendas. Taken together, these four aggregate dimensions and their underlying second-order dams form a comprehensive framework that explain how IoT can support entrepreneurial success from individual capabilities and organizational culture to technological infrastructure and broader ecosystem value creation. For RK2, we classified future research directions across micro, meso, and macro levels. At the micro level, studies should explore digital skill formation, entrepreneurial cognitions, and experimentation behavior and team dynamics in IoT-enabled ventures. At the meso level, the research can investigate structural alignment, cybersecurity governance, scaling processes, and organizational learning for IoT and AI combined innovations. And at the macro level, future studies should examine ecosystems, regulatory framework, institutional voids, digital divides, and how societal networks support IoT adoptions. This level provide a multi-layer roadmap for understanding how IoT-enabled entrepreneurship evolves within the broader technological and societal contexts. Our findings show that IoT-enabled entrepreneurship is shaped by four interconnected dimensions. First, digital entrepreneurial human capital. Second, digital organizational readiness and culture. Third, digital technological infrastructure and innovation systems. And digital value creations, ecosystems, and societal impact jointly shape IoT-enabled venture performance. Success is achieved not by isolated adoptions, but by aligning strategic intent, research, preparedness, and learning-driven adaptations. To conclude, this study contributes by integrating and validating a unified set of success vectors that explain how IoT supports entrepreneurial activities. The findings also offer practical insights for entrepreneurs, organizational leaders, and policymakers. However, the study is limited by the relatively small number of IoT entrepreneurship publications available and the uneven distribution of evidence across sectors. Future research should continue exploring IoT impacts at multiple levels and examining how digital entrepreneurial ecosystem evolve alongside connected technologies. Thank you very much for your attention. I appreciate the opportunity to share this research at ICDTDE 2025.